Bismillah ar-Rahman ar-Rahim. This is lecture 3, a continuation on the lecture on determinants. It's about permutations and cofactors. If we perform a row exchange, then P times A is L times U. So the determinant of PA is determinant of P times determinant of A equal to determinant of L times determinant of U. For one row exchange, determinant of P equals -1. Hence, determinant of A is minus determinant of U, since determinant of L equals 1. In general, determinant of A is plus minus the product of the pivots, D1, D2 up to Dn. The sign is negative if the number of row exchanges is odd. Example. Here A has rows 3 and 1 interchanged, so P is this matrix whose determinant is -1. It will now exchange rows 1 and 3 to put the matrix in upper triangular form. So PA is this, whose determinant is the product of pivots -4 times 2 times 1 equals -8. Another example is the tridiagonal matrix, which does not require row exchanges. Okay. Moving from A to U, the pivots are 2, 3/2, 4/3, and 5/4. So the product is 5. Okay, this is the determinant of A. Here L is this matrix. You can check LU equals A, and its determinant is 1. If we consider the 3×3 matrix, A, whose elements are A, I, J, I is the row index, J is the column index. Okay, and if we apply Gaussian elimination to get U, using the first multiplier for the first column is A21 over A11, and the second multiplier for the first column is A31 over A11. So elimination gives us this matrix. In order to simplify, let us just try to use abbreviations. The second pivot here is the determinant of A2, which is the subdeterminant formed by the upper left corner, A11, A12, A21, A22, and it's divided by A11. Let us introduce the other abbreviations: determinant B1, determinant B2, determinant B3 for the other terms here. So here we eliminate below the second pivot with multiplier determinant B1 over determinant A2. Okay, and we come up with U. So the third pivot is here, D3, and if we combine by taking the common denominator, A11 determinant A2, we have this. Okay. Let us expand D3 term by term, and if here, since it is divided by A11, A11 has to cancel, and you will see that the terms that do not have A11 in them will cancel, so we will be left with 6 terms only. Okay, so the numerator of D3 will be A11 times the determinant okay, formed by deleting row 1 and column 1, and then A12, then A11 times other determinant. Now if we divide by A11, D3 is now 1 over determinant A2 times this. This is when we remove the determinant A2 after multiplying the pivots. Okay, we will have this for determinant of A. So here A is A11, A22, A33 minus A11, A23, A32. Okay, note here that those terms have the first index in the order 1, 2, 3. All of them. All 6 terms have this for the first index. But for the second index, we do not have this order. The first term had this 1, 2, 3. But the second one was 1, 3, 2 for the second column. So this formula here is what is called the big formula for determinants. Okay. And note here that each term has an element from every row, with I, the row index, which comes first. The first index in all terms is 1, 2, 3. However, the second index does not always follow that order. If the second index follows 1, 2, 3 counterclockwise, it is positive. Thus 2, 3, 1 and 3, 1, 2 are also positive. So you can see here the negative terms had the order in a clockwise fashion, 1, 3, 2 or 2, 1, 3 or 3, 2, 1. And the sign is negative. That fixes the sign on each term in the big formula, expansion of the determinant. This is connected with permutations and can be seen by using property number 3 of the determinant as follows. So if we take A and apply the linearity property, it splits into these 6 matrices, 6 determinants, which may be written by using permutation matrices. So the first one is A11, A22, A33 times the identity matrix. But the second one has 2 row exchanges. It's A12, A23, A31 times P23 and P31. And the third one also has 2 row exchanges. 2 row exchanges means a positive index, but the other 3 determinants here have the order of the columns 1, 2, 3, 1, 2, sorry, it's for the first one, 1, 2, 3 is positive, but for the fourth term here, it is 1, 3, 2. 1, 3, 2 clockwise, so negative. Okay. And also the fifth term has the order 2, 1, 3. 2, 1, 3. That's clockwise, that's negative also. And the sixth term has the second index 3, 2, 1. 3, 2, 1 is clockwise, so negative. So that fixes the sign in the big formula expansion of determinants. Now the expansion using cofactors is easier, and we do it as follows. So by deleting first row and first column, we have A11. So So we are expanding by the first row. A11 times the subdeterminant obtained by deleting row 1, column 1. Then we have the second one, A12 times the determinant obtained by deleting the first row and the second column. Okay. The last one is A13 times the determinant obtained by deleting the first row and third column. Okay, so we can write it in compact form as A11 C11, A12 C12, A13 C13, and C11 is minus 1 to the power of I plus j, which is 2, times the determinant M11, which is the submatrix obtained by deleting row 1 and column 1. C12 is minus 1 to the power of I plus j, which is 3, minus 1 to the 3 is minus 1, times determinant M12, which is the submatrix when row 1 and column 2 are deleted. Similarly, C13 is minus 1 to the I plus j, which is 1 plus 3, which is 4, plus 1, times determinant M13, which is the matrix obtained by deleting row 1 and column 3. So Cij is the cofactor of element in row I and column j. We can also calculate the determinant by expanding down column j. So instead of expanding by the row, expand by the column. So determinant A becomes A1j in the first column. Okay, C1j plus A2j, C2j plus ANJ, CNJ. And always Cij is minus 1 to the I plus j determinant Mij. This formula is usually the easiest, and we usually expand using this cofactor formula.